one-way repeated measure of ANOVA in SPSS. Repeated measure of ANOVA is used to compare mean difference of different groups when the respondents are remain same for each group. We can use repeated measure of ANOVA to see the change in the effect of intervention in different time points or to compare the response of participants to more than one condition. So let's see an example how can we perform a one-way repeated measure of ANOVA in SPSS. So this is the SPSS data file, and you see that we have three variable. This actually indicates that three conditions, and one is the pre, month 3 and month 6. So basically here we want to see the impact of medicine on body weight gain. So we want to see if I use a particular medicine, then whether it actually helps to gain the body weight. And this is our participants, and our participants remain same throughout this experiment. So that means that our sample or respondents remain the same. Okay, and this is their preconditions. That means their body weight at a precondition, that means before using the medicine. And month 3 means after using the medicine, what happens to their body weight. And month 6 means what happens to their body weight after using the medicine, after 6 months of using the medicine. Okay, now to perform the one-way repeated measure of ANOVA, we need to go to the analyze, and then you see general linear model. So analyze general linear model, and then you go to repeated measure, and within subject factor name, so here the more appropriate name could be time, because I want to see what happened to your body weight at different time points after using the medicine, right? So the factor name should be time, and we have 3 time point: pre, month 3 and month 6. So number of level should be 3, and then I press add. And measure name, since I measured this is a body weight, so I can say that we can write a body weight kilogram. Okay, so I just write kg. So body weight kilogram is an indication of the measure name. So after writing the body weight kilogram, I press add, and then I need to define this in this repeated measure within subject variable box. So for the first one, this is the pre. So if I click this one and then pre, and then is this button, it will go there, and then I need to click the second one, and this is the second column. You see this is the for the month 3, and the last one is for month 6. Now under these different options, I will click on the plot, and I put time in the horizontal axis, and then press add, and then continue. Next I will click options, and under the options I will click the time, and I will send it to the display mean for compare main effect. I can choose any of these, so I'm just clicking Bonferroni, and under the display option I am clicking descriptive statistics and estimates of effect size, then continue and OK. Now you will get the output of this repeated measure of ANOVA. So simply if I look at the profile plotting, you can see that this is the precondition, this is the effect of the medicine after 3 months, and this is the effect after 6 months, right? These three different time point. And from this profile plotting, you can see that over the time point, that means after the using the medicine, you see this is the pre. Now your body weight has increased, and it has further increased after 6 months. Okay, and if I look at their descriptive statistics, I can find that the impact of the medicine on the body weight, especially in the pre condition, that means before using the medicine, the mean body weight was 54.61 kilogram, and now after using the medicine in month 3, uh, it has increased to 55.01 kilogram, and after 6 months it has further increased to 58.78 kilogram. Now the question is that whether the impact of this medicine significantly differ between these three time point. So if I see at this multivariate test, and if I looked at the Wilks lambda, you see the significance, the p-value, it is actually statistically significant, right? So this means that uh, there is a significant difference in body weight gain in three different time point. Okay, now if I looked at the Mosley's test for sphericity, and the significant value, you see this is the p-value, this is actually statistically significant. And if this is statistically significant, that means there is a violation of the sphericity assumption. If there is a violation of the sphericity assumption, in that case, when we actually interpret test within subject effect, uh, my decision will be based on the greenhouse gaser significance value. Okay, so in case this is the p-value, you see this is statistically significant. Now my main focus is to look uh, at what level actually this varies, and whether this is actually statistically significant. So if I looked at this pairwise comparison, so this is the body weight at different time point comparison. If I look here, you see that from time 1 to time 2, this is I minus j, so this is the mean difference. So mean difference is minus, that means time period 2 has more value than time period 1, because this is the minus sign. In other words, if you look at the second one, so 2 minus 1, this is positive. So this means after using the medicine, your body weight has increased on an average 0.40 kilogram, and it is statistically significant. Now if I compare with third period with the preconditions, now you see from third period to the preconditions it is positive. So that means your uh, body weight has increased about 4 kilogram compared to the pre-medicine condition, and it is statistically significant. Even in the third time point, that is mean after 6 months of using the medicine, your body weight has increased more than uh, the effect on your body weight that is in period 3. So you see that the difference is 3.77 kilogram, and it is also statistically significant. And this same thing you can see through this graph, right? So it has gradually increased, and the difference is statistically significant. So in this way we can perform one-way repeated measure of ANOVA in the SPSS.